Well, hello there. This is Craig Hain. My students call me Dr. Dell, and I want to talk to you today about an absolutely horrible situation we have in our mathematics education in the United States. You can download a free PDF copy of my book, Teaching Math, which I wrote about 6 years ago, that describes all of this and also describes then a brand new program we've developed which really solves this problem. But I want to, on this video, make you aware of just what the problem really is. Now, in order to do this, let's start off and let's have a little fun. I'm with the supercomputer here, and I've set up a problem that I saw this on YouTube the other day. There was a guy that was giving an interesting talk over in England, and he said, well, here's a problem. Let's take any two-digit number, let's call it AB, where A and B are just digits from 0 to 9. And let's multiply that two-digit number times itself 3 times. And he let him use a calculator to do that. Now, we know that would be taking that number and cubing it. And then he said, now the problem is to find AB, given that number. So here, for example, is a number, 50653, that is some two-digit number that's been cubed. And what is that number? Now, he proceeded then to give the answers rather quickly. So, for example, in this case, he gave the answer right away, and he said it was 37. Now, we can take a calculator and go and see if we believe that is true. We can take a calculator, for example, here, and I'm going to take 37, enter it into the y to the x key, hit 3, that means I'll cube it, and I get 5653. So 37 was the right answer. And he did that, though, in his head without a calculator. And then he proceeded to do a whole bunch of them. So, for example, he came to this next one, let's say. And let's see, what would that be? He did it in his head, and he said that would be a 29. And so now we can check that with our calculator. 29, I'm going to clear the calculator. 29. Y to the x, cube it, and let's see if we get 24,389. Sure enough, that worked. And he did it in his head just that fast. Now, he didn't tell anybody how he was doing it, so people were thinking, wow, this guy is really sharp because he's taking, in essence, a cube root in his head in just a matter of a few seconds, and how did he do it? So I thought about it and played with it, and I came up with an algorithm to do that. So now I'm going to use this cheat sheet to do this, and I'm going to do the next one, and it's 421,875. I look at my cheat sheet, and I see that's going to be a 75 is going to be the answer. Now, we want to check me and see if I'm right. Let's take 75, and let's raise it to the third power, and we get 421,875. Sure enough, it's right. Now, you can stop the video and look at this cheat sheet and see if you can figure out how I'm doing it. It's a little algorithm that I figured out to do it, and it's not hard to do. And this next one would be, let's see, it would be 8, 1. So 81 is the answer, and let's see if I got that right. 81. Y to the x, 3 equals 531,441. Sure enough, I got it. And this goes on down. And now I'm going to do one more here. Let's see. This one would be, what would this one be? This would be 93. And I use my little algorithm to do that, and I'll let you check that out. Well, in fact, let's just do it together real quick here. 93. 93. Y to the x, 3. And sure enough, that's 804,357. Now, let's take another number very close to this and see what would it be. Now, we know this number would be essentially very close to 93. It would be like, it's a little less, it would be like 93.999. But if I use my method to do it, my method would tell me that the answer is 96. My method would tell me that. And of course, that's not right. So this would be a mistake. My method is only good if you have a perfect square. Let's do this one. Let's see. The number to that is going to be 5, 9. 59. So let's see if that's right. 59. Y to the x cubed equals 205,379. Sure enough, but now if I go down and do the next one, if with my method, the answer I'm going to get is going to be 52. with my method. And of course that's wrong because it's going to be just almost 59. So my method only works, this algorithm only works. Now, I went ahead and did a few other examples here, and I'm not going to go and belabor that. I'm just going to point out some things here. How many numbers are there between, this is 10 cubed will be 1,000, 99 cubed would be 970299. So you've got between 1,000 and 970,000, you've got almost 1,000,000 numbers here. And there's only 90 of them that actually meet the format. So if I picked out a random number and tried to do it, I picked out one here, my method would tell me, I just picked out a random number, my method would tell me that it is going to be a 6, 8 is what my method tells me. But let's see what it really is. Now in this case what we're going to do is we're going to take 258, 962, and I've got a scientific calculator. I'm going to take the cube root. I want the cube root of that. And if I'm doing it right here, I think it's down, where's the cube root? Right here. And the answer is 63.7. So I didn't come very close, did I? My method is not very accurate. And so if you just pick a random number in this range and apply my algorithm, you're not going to get a very good answer. But you will get the exact answer for these particular ones. Now, here's the problem. Here's the question. Is this an algorithm that we should teach our kids? I didn't teach you how to use this yet. You maybe figure it out on your own. I've given you quite a bit of hint here with my crib sheet. Of course, I can memorize all these numbers, and then I can do all this in my head very quickly, just like he did in the exam. So the real question is this something we should teach our children? Now, my answer to that would be, well, why would you do that? How often are you going to run into a situation where you have a two-digit number that's been cubed and you've got to find the cube root? You tell me. In my view, that doesn't happen very often. I can't remember ever having to do this problem. So here's an algorithm that's interesting. It lets you do something that's kind of neat if you want to get up and do a little stage show, or if you want to have some fun, maybe bet somebody or impress them. When you do this, and it takes you about 10 seconds to say, oh, the cube root of this number is 75. It's go, wow, that's a pretty smart guy, maybe. Actually, I'm not that smart. I just know how to use this little algorithm. So the point is, this is not something we would probably teach our students. Now, here's the real problem. We actually do this sort of thing all along in our math today. We have all sorts of things where we teach our students something to do, and then we make them do it. But it's not something that they're going to have to do very often. Now, here's an example. We're going to take three factors here: 2x minus 3 times 3x plus 7 times x plus 2, and we're going to expand that. Now, Wolfram Alpha, I entered it into Wolfram Alpha, and it said expanded, and here's the answer. Right there's the answer. And over here it had a step-by-step solution, which I clicked already. So now it's even going to tell me how to do it step by step. And so you go down here and it says, okay, the first thing you do is you take two of these factors and multiply them together and you get that. Then you multiply that times the third factor. It even shows you longhand how to do it. So if you were teaching a student how to do this, and by the way, we do this in algebra all the time. This would be a typical problem in a beginning algebra class. We would make the student learn this method of doing it. It's not terribly hard. It just involves using the distributive law and a few of the rules of arithmetic. So it's not too hard to do. This is a problem you could easily give a student. And in fact, then this is how we make up problems. We say, okay, now I know this polynomial. I know what its factors are. Here's its factors. I made it up. I took it here and I expanded it. There it is. So now what we do then, the next thing we do, and this is done in a typical algebra class, we go, okay, Mr. Student or Miss Student, we're going to come down here and we're going to say, we're going to give you that polynomial. And let me try to get down here. Move them down. I've already put it into the... Notice that Wolfram Alpha gives you a lot of other information that you may or may not care about. Okay, I moved it down here and I said, okay, let's factor that. And I put this polynomial in to factor. And then it factored it for me. Of course, we knew where it came from. I made it up. This is what teachers do, by the way. They take something where they know the answer, they work it, and they say, now factor this. Now, what's the step-by-step solution of this? And this is what we teach our kids, by the way. I tutored a gal here a year ago, and she was in tears because it's hard to do. It says, here are all the possible rational roots. This is called the rational root theorem. And here's all the possible answers to this. All these are rational possible routes. You got to go test every one of these. This could take you an hour to do this manually. And finally, you figure out, well, there's 3 of these rational numbers that are actual roots. And once you know that, then you can come up with the factors. Now, this is a really, it's not terribly difficult, but it's a very time-consuming thing to learn. Furthermore, with a modern tool today, why would you ever want to learn this manual technique? Now, that's the point I'm trying to make at. If you're a teacher or a parent or if you're whoever you are, why do we want to teach our students an old manual technique? Now, our ancestors did this years and years ago. Back before they had computers and tools, they spent a lot of time doing stuff like this. But this is what I would call an obsolete manual tool, and yet we give them. Furthermore, it rarely works. If I give you another problem that's similar to this and ask you to factor it, it won't do it because the facts are there aren't any factors. Most of the time, when you have a problem that comes up in science and engineering, there is no manual technique that will solve it. Now, I'm just giving you a couple of examples here out of algebra that are really pretty simple. When you get into calculus and differential equations, it gets even worse. We have literally hundreds of manual techniques that have been developed by our ancestors back before they had computers and tools, and that's what we teach our kids today. And it's just horrible because no one will ever use these tools. You're going to use a modern tool. So what should we be teaching our kids today? Well, I think we've got to teach them the concepts for sure, but not the old manual tools they'll never use, but teach them a new tool, like how to use Wolfram Alpha, for example. That's what I do in my 6 tiers. I can take a student when they're like, let's say, 12 years old, 13 years old. Not a genius, just a reasonably bright, ambitious student. And in 2 years, we can have them through calculus and understanding it well enough to go and do any kind of an engineering or science problem they're going to run into at MIT. And differential equations as well. I mean, 2 to 3 years, and they learn that. So by the time they're 15 years old, they've got all the math they need for science and engineering as far as calculus and differential equations goes. Not only that, they've not only learned to use a powerful tool, but then they'll be able to go ahead and learn even more advanced math with it as time goes on, as they'll need to, but always using the tool. So that's the point I kind of wanted to make today, is that we have a situation today where 80%, I'm going to estimate, of the things we're teaching our students is obsolete. It's things that we shouldn't be forcing them to learn. And what you can do is you can go to our syllabi at our website and look at all the 6 tiers we have and look at the syllabi and then compare that to the syllabi of what's being taught in our standard math curriculum. And I think that if you can understand the math, then I think you're going to quickly realize that what I'm saying is true and how we're really mistreating our kids today by making them learn a lot of obsolete things. I make the analogy of carpentry. What if you wanted to hire someone to put shingles on your roof, let's say? Are you going to pay them to get up there with a hammer and nails and do it manually, or are you going to have use a nail gun and do it professionally the way modern carpenters do it? It's much less expensive to do it with a modern tool than it is with the old manual tools. In fact, anybody that does modern carpentry today uses power tools. Well, that's what we're talking about in mathematics. Let's teach our kids to use power tools, not the old manual things that they'll never use anyway, and that are very difficult to master. It's very difficult to master these manual tools, and they don't work a lot of times. Many is a problem that you can't even do with a manual tool. So this is Dr. Dell. Enough for my discussion of this, or my rant if you want to call it that, but it really is a big deal what we're doing to our kids today, and I think that more and more of us have to become aware of it and do something about it. So this is Dr. Dell. I'll see you on another video.